So, as Satar was saying, I'll be telling you about COBIDAS and more specifically, actually the eCOBIDAS, which is like the sort of online checklist version of it. And the subtitle of the presentation was because methods writing is too important and boring to let humans do it. Okay, I'll jump right in. And first, actually, before I forget, I prefer to do that at the very beginning. And I just want to sort of thank everyone who's been involved in this project. The project has been actually just sort of leapfrogging from hackathon to brain hack event. And that's how it's been sort of moving forward. And that's how it has also sort of like grown in size with more and more contributors. And I would like to also give a special thank to, well, Sanu who is here, who's been doing crazy amount of work to actually help make this thing run. And also to Satra, who's been just really helpful in giving a lot of feedback and inputs on how to sort of organize a lot of this. Okay, so I'm going to start with a series of very rhetorical questions, but the idea is just, have you ever, when planning a study, or maybe in some cases, if you are writing a pre-registration for a study, or when you're writing a paper, has it ever happened that you sort of overlook some design or analysis issue or details that you didn't put it in the method section, or that you were unsure of actually what level of detail you should actually put in your method section? That is usually the case the first time you write your paper, a paper as a PhD student, for example. You've never done that before, and you have no guidance or very little guidance sometimes, and you're not sure how to go about this. Another situation is when you're writing your method section, or when you're submitting a paper to a journal, or when you're uploading your imaging results to NeuroVolt, which is a website where you can just share your statistical maps for fMRI, for example. Have you ever had to sort of look up or copy paste some details from related to the MRI sequence you used or to your experimental design, which usually then involved you having to look into some like old scripts or just some PDF about which sequence you use at the scanner? And I'm mentioning the journals here because a lot of more and more journals actually have sort of their own checklist now about where you have to report some methodological details. So usually you end up doing the same thing when you write your methods, when you submit your journal, and then when you share your data. And usually having to repeat things is something we don't want to do, and it's just usually very inefficient, and we might just miss some things when we do those copy paste. It's usually like a source of a lot of potential errors. And finally is like when reading or reviewing a paper, or when wanting to replicate a study, or when you want to compare your results to those of another study. Have you ever had the feeling that there was too little information in the method section, and therefore you found it hard to make sense of the results, or even just then may find it hard to even compare your results from your study to their study, because there was too little information to figure out what the authors had done and how they had got those results and how it compared to your results? Well, I suspect that quite a few of us have been in that situation before. And it's not, let's say it's just not uncommon. And why is that a problem? Well, the idea is that if you, I'm going to try to use the pointer. Yes, that'll be better. Right. So the idea is that I'm going to be just using those terms here just for the sake of just like that for that slide, though I know that those terms usually have, you always should agree with people before you start discussing them, because not everyone just agrees on their definition. But the idea is that if you say that a result is reproducible when you get the same, when you use the same analysis on the same data, and you say the results are robust if you use the same data, if you get the same results by using the same data but using a different analysis. The problem then is if you're unclear about if the analysis is under-specified, meaning you don't have enough information to sort of figure out, if you're using exactly the same or something very different or sort of in between those two, then it makes it really hard to just figure out what you're doing and how to compare results, and whether you're just are actually working on reproducibility or robustness. And it also applies whether then if you work on with different data set, whether you're just working on replicability or generalizability. So just the idea is that if you have poor methods and also poor results description or reporting, that can lead to a lot of inefficiencies because we waste a lot of time trying to figure out what other people have done or trying to compare results or basing our results on things that are not clearly understood. Okay, but that, okay, and that feeling that some of us might get from our personal experience is just more than just anecdotes, actually. So in 2012, Joshua Carp went through a systematic, not a systematic, he went through about, let's say, 100 papers, maybe, I don't remember whether it's 100 or 200 papers from the fMRI literature, and looked at what was reported in the method and the results section of those papers, and sort of comparing to what you would expect should be there. And so if you look just at the acquisition parameters, which are fairly objective things to be reported in a paper, there's not, it doesn't necessarily, it's not like, it's usually a fairly just black and white situation of what those parameters actually were. You find out that a lot of papers do not report information that would be necessary if you wanted to sort of reproduce or to replicate those results, right? If you want to sort of have the same sort of MRI sequence, you definitely, I mean, obviously the TR, for example, for a functional scan is reported, but like the voxel dimensions are not necessarily like only reported in less than 50% of papers, right? Which kind of makes it hard to then just replicate the results. Things get even worse for anatomical scans, and it depends on, and auxiliary scans like field maps is also a bit of an issue. And you've got the same problem when you're looking at basic things like pre-processing, where except for, when you do sort of motion correction, you specify which volume you use to as a reference, or when you do normalization, which sort of space you normalized in, and which kernel you use for smoothing. Except for those, all of the other parameters are usually reported in less than 50% of the time. So that means that there's definitely a large room for improvement when it comes to methods reporting. And that kind of thing tends to get me a bit annoyed. So what we all do when we get annoyed is that we take it to Twitter, and I think that's one day I just had enough, and it's what I read one of those papers, and I just posted, when I see that the whole pre-processing part of an fMRI paper is the data were realigned, slice time, normalized, and smoothed using SPM12, I sort of feel like I want to send an email to the author, letting them know, sharing my recipe to my best chocolate cake ever, and I just tell them, yeah, the recipe is just mix the ingredient and put in an electric oven. I'm not gonna let them know how much of what ingredients, temperature of the oven, and things like that. No, those are details they do not need for my recipe. So yeah, it pretty much turns out that a lot of the papers we have in the literature are no better than a very bad like recipe, and I'm not the only one to get annoyed by this. So after this paper came out, the OHBM, so the Organization for Human Brain Mapping, created the Committee on Best Practices in Data Analysis and Sharing, or COBIDAS for short. And that committee sort of then went on to produce two reports, one for MRI and one for EEG and MEG. And those reports give a very highly detailed list of what should be reported in terms of methods, and also how results should be reported for MRI studies, whether functional or just purely just anatomical or diffusion type of analysis, and for EEG and MEG studies. And if you go through the reports, a lot of them they just read pretty much like, a typical paper, and it will tell you for experimental design, here's what you have to report for the acquisition parameter, pre-processing, and so on. They will like give you a list with justifications of why you should report this and that. And if you just take the MRI report, it's a PDF that's about 70 pages long. And but they had the good idea. They had a very good idea to actually add some sort of checklist under as a form of a table next to it. It's still pretty much like a 40 pages long checklist, and it sort of mixes all the different use cases, meaning that if you are doing a vanilla fMRI study with one anatomical scan and one functional sequence, you're still going to be, and you do just a mass univariate analysis, you're going to have to flip through pages and pages of items that do not concern you. Right? So it's very good to have sort of a standardized format to sort of check that you've got everything. The problem is that the user friendliness of the format is not yet quite there. So I was thinking about all this, I think it was a bit more than 2 years ago. And one of the first things that came through my mind was like, if only we had at least like a bit more of a standardized spreadsheet that we could just like go through and we could sort of filter, and then at least I would make things a little bit easier, right? And then a couple of months later, I think it was, March 2019, Cassandra Guvan-Prag just posted this on Neurostars, and where she just said, so here's the appendix of the eCOBIDAS MRI report, Appendix D, which is the table I was mentioning. And she had just broken it down into a list of items, like atomized as much as possible, as much as she could, so that it would be easier to just then use, right? So I was just, I just automatically just reached out to her and say, this is gorgeous and fantastic. You've done this is like the first step to this project I have in mind. And started getting in touch with her and going, so are you going to OHBM hackathon? Maybe we could just like do something about this. And so we did. So literally this was, sometimes people ask you about a hackathon, and they say, okay, what do you need when you go to a hackathon? How like, do you need like a full-fledged project, and does it need to be super advanced? And a lot of people say, nope, you can just come there with just an idea and that's enough. And that's literally one of that case. It was just Cassandra and I, and it was an idea and a spreadsheet. And the idea was like, okay, we want to make the eCOBIDAS report easier to use. And how? Well, we don't know how we're going to do it, but we want to sort of create a web app that's going to be just like a clickable checklist. And ideally, this checklist, we wanted to sort of, in the end, be able to automatically generate the methods section of a paper. And the funny thing about the whole eCOBIDAS project is that it's still like, this is still pretty much the goal. Like, we have made huge progress, but this is like, we're still going in the direction, and this is still fairly up to date, I would say. Obviously, you're going to see that there's a lot more than just this, and there's a lot of extra sort of like little things that have appeared, and said that we have more ideas. But this is just pretty much the pitch of for the rest of the talk. So I'm just going to first go through like how we sort of have come up with a web-based clickable checklist. And so the idea of, a hackathon is you get idea, and then you throw those ideas and in a crowd of compulsive helpers, and some sort of magic happens there. And what happened is that what I did not expect, I literally expected that I would be just working on this with Cassandra for like 3 days and that would be fine. And then we ended up with like 6 or 7 people who were just like, yes, we want to help. So then suddenly we had to sort of figure out how to organize a team and lead a team. So, which was also a very interesting experience where you were not prepared for this. And so what happened in that in that one of the things that happened during that hackathon is that we sort of finished turning the whole COBIDAS report into an extensive like spreadsheet and tried to sort of refine the work that Cassandra had done, and also worked on the MEG part that Cassandra had not touched because at that time the MEG report was just not fully finalized yet. So we were already sort of going ahead and just like trying to move forward on that thing as well. The other thing that happens at a hackathon is that you get to meet people who can give you a lot of input on how to get your stuff done, right? And so I bumped into Tom Nichols, who was like, have you heard of the semantic web? And I said, yes, it rings a bell. But when I meant it ring a bell, I think I had no idea what it actually really meant. Like in hindsight now, I'm like, okay, no, I clearly had no idea what it meant. But it sort of like took me like to the side and said, okay, let's go and talk to Satra. And so we started talking with Satra, and then sort of introduced me to the ReproSchema. Or what was going to become the ReproSchema. I'm not sure he had that name at the time. And so as Satra mentioned, there's been a talk a few months back here on one of the webinars about what the ReproSchema is. I'm just going to go very quickly just to give you a broad overview of what it is. But if you want to know more, I suggest you go and watch that webinar. I'm just going to stick to what I need you to know for the rest of this talk here. So the idea of the ReproSchema is that you want to harmonize data sort of by design. And the idea is that you want to make sure that when people respond to a questionnaire, the output you're going to get is the format of the output you're going to get is going to be standardized automatically because the input is standardized, and sort of the user interface also gives you a completely standardized output. And you know, if you had to sort of literally make a flow chart of how it goes, is that you have your questionnaire as a spreadsheet with an item on each row, for example, and you convert that into a set of JSONLD files. I'm not going to get into too much of the details of this, but that format is fully standardized, and this is read by a user interface that's like based in JavaScript. And once the user has clicked through what the user interface is showing him, then you can also export a set of JSONLD file that's like fully standardized and will also sort of link the input to the responses of the user. One thing that is important in this is that items or set of items, for example, get a unique identifiers, meaning which type of item it is, for example, or give them a unique ID, and also some you also have some defined properties, meaning what type of input the user should give, the question to ask, and which type of response options the user can have, for example. Okay, and so what we did for the eCOBIDAS project is that we started by trying to sort of apply the ReproSchema, but we didn't want to use like the 500 items list from the whole COBIDAS thing because it was a bit too big to start. So we went for a subset of items, and the best to sort of work on a prototype. And the way we did this was that by using the metadata from that are required, or that you can sort of fill in when you upload a data set or some images to NeuroVolt. So NeuroVolt, when you upload your fMRI results there, for example, they're called collection, and for each collection you have a set of metadata you can fill in. And why we use those, well, first of all, it's only 100 items, which makes it much more manageable, at least at the beginning, to sort of like work and wrap your head around of how the ReproSchema work and how user interface work, and so on. The advantage is it's also actually a subset of the of items from the eCOBIDAS MRI. So if we start sort of working on those items, we can then reuse them later for the full MRI eCOBIDAS. And it also turns out that even if you only sort of report those 100 items, you're already doing way better than most paper in the literature. So it was like, okay, even if the product just stopped there and we only had this, a web app based on this, that would already just help improving reporting in the literature in general. Excuse me. Another idea is that one of the long-term goal of the project is that we want to be able to, when we share results or when we share data, we want to be able to sort of associate those data, those results with a machine readable version of the method section of a paper, right? So the idea is that if we start working from what NeuroVolt wants as metadata, then we can sort of, one of the potential goal of this is that then once the app creates a set of JSONLD file that sort of summarizes the method section, we can then use that set of files to sort of share with a data set that we upload on NeuroVolt. So the idea is trying to sort of reuse some of the existing sort of either tools or standards that exist sort of in the ecosystem of neuroimaging in general to sort of make our life easier. So what I'm going to do right now is give you a very quick demonstration of what the app looks like and how you can use it. And hopefully you should be able to see everything. So, okay, so this is the repository where the code of the app is hosted. And if you actually want to use it, you would just need to go there. And so this would be the landing page of the app telling you plenty of information of how to use it and how to sort of find more information and so on and so forth. But the main part is that the app is divided in sort of sections, I would say, that would go pretty much through the main sections that you would have in any paper, meaning experimental design, participants, MRI acquisition. And then you can just start working on the app by just clicking on each part and start the different parts. So number of imaging runs, I don't know, I'm gonna just go through a series of those. Oh, okay, I already filled it in this afternoon, so it still remembers what I've done. There is a certain level of input checks that is happening. So you can see that you have like, multiple choices. You can check for whether you expect a numeric answers or something like this. And you can sort of jump through to another section and just keep filling in it there. And we're just like, you just go through all the questions like this, and we'll keep track of what you're doing. Pre-processing, for example, we'll ask you which software you use for analysis. We'll ask you for version of the software, SPM12, for example. Could ask you for the order of the pre-processing operations. If you had any sort of quality control measures. So all of those items actually are just the typical things you would have to fill in when you upload some data on NeuroVolt. B0 distortion, word slice timing correction use, and so on. And then, and what happens is that, for example, if you say you've used slice timing correction, it will ask you the software that you have used if it is different from the main package. But if you had responded no, then that question would not be asked of you. So there's a certain level of sort of branching logic, meaning that you're not going to be exposed to items that are not relevant to your use case, right? So that's one of the things that I was mentioning earlier, that you don't necessarily want to have to respond to items that concern, I don't know, like diffusion imaging or arterial spin labeling if that's not a method you have used in your experiment. And then you just can carry on responding to all of those and those different sections, and then you can sort of export the results. And what this does is that it sort of downloads a little zip file that contains just a set of JSONLD file, and there's one for each of the section you've actually filled in, and this sort of summarizes I can open one, but obviously this is machine readable. It becomes a bit harder to read for a human being. But this is the output you get from the app at the moment. Okay, I'm just going to go back to my slides. Are they full screen? Yep, I think they are. Okay. And so, yeah, the idea is that at the moment you get a set of JSONLD files that are machine readable and that are linked to sort of the exact questions that were asked and the answers you gave. So another thing that that's important to mention about the eCOBIDAS project is like, and on one of sort of like the goal of the project is just that it's not necessarily just about trying to create a tool for fMRI and MEG. The idea is to actually create tools to generate that type of checklist, but that should be sort of more, it's not domain specific. The idea is that you could be able to apply it to another field of research where they need a checklist to report methods, and that would be just fine. The only thing you need is pretty much a spreadsheet, and then you could just run it through sort of our pipeline, and then you would end up with an app that would behave exactly the same way. One way that I did that was that there was a few months ago, there was a preprint that came out about sort of trying to also give guidelines on how to report eye tracking research, specifically when it came to decision making, but that's not actually doesn't matter here. But and I just wanted to make sure that try to see if I sorry. So that paper actually I need to mention maybe that preprint also came with a table, obviously, of all the guidelines that you're supposed to report. And, I just wanted to make sure that it wouldn't be too hard to convert that table into its own app. So, I took a couple of hours, maybe a bit more, to actually do that. And now there's also an app to help you to make sure that you've got good reporting of your methods for eye tracking results, for example, or for an eye tracking experiment. So yes, that's one thing I want to mention. So now I'll need to tell you a little bit more about the aspect when it comes to generating method section automatically. So this part is much more work in progress. So at the moment, so it's going to be mostly a lot of like flow charts to tell you where we are and where we're going. I cannot show you the app in action. But I want to mention that this is a very important part of the project for a very simple reason, is that I think that this is pretty much sort of, those tools we create are only useful if they are actually used by people, right? And I think that a lot of us, even if we really are, we care about reproducibility, but I think the only way we're going to get people to adopt those tools is that if there is something in it for them, right? So I suspect that one aspect of that tool that would be very useful is that if people do not have to write their own method section, and if we can show them that by using an app, it can do it better and with fewer mistakes, then they would do it, right? And also faster. And that also it has all the side effects and side benefits that are interesting for them. So that's pretty much sort of the carrot for me to sort of tell them this is going to be useful for you, right? Because I think for most people, if we tell them, for most researchers, if we tell them here's a set of JSONLD files that sort of summarizes your method section, I think for quite a few people, their reaction would be yes, and so what? So I think that this is sort of the next important step of the project that needs to sort of get working to sort of make sure that there's a higher sort of adoption of that kind of tool. So this is just big idea of how this works. Once you use the app, you get a set of JSONLD file, which, as I said, is just a machine readable version of your methods. And the idea is that on the side of that, you've got, let's say, some boilerplate method section just with some empty gaps. And then you can use some of the several sort of templates, creating tools like, I'm just highlighting here Jinja for Python, that you can then use with those two inputs to create a human readable version of your the method section. So once again, that's not exactly how we're going to do it at the moment, because once again, we want to sort of start with a simpler problem, because generating an entire method section for an entire paper would be too complicated. So right now we are starting with, let's try to sort of have the method section for a BIDS data set. So if you've never heard of BIDS, it stands for Brain Imaging Data Structure, and it's just a way to sort of organize your data and the metadata about some brain imaging experiment or study. So it could be MRI, it could be EEG, MEG, and so on. And because this is a highly structured because this is highly structured and you know where the data is and where the metadata is, it is possible to sort of extract the metadata from this, and using the same approach, having a boilerplate that would be the description of that data set, except for all the specifics of that data set, then you're able to create a human readable description of that data set. At the moment, actually, you have two packages or toolbox like PyBids in Python and BidsMATLAB for MATLAB and Octave that can sort of do that. They can do it for, to some extent, for MRI data sets, but not for EEG and MEG. And also, each of them has a tendency to sort of like the, let's say the boilerplate, let's say the text with the blanks in the middle is sort of part of the code in both of those packages, right? So one of the goal of that what we're working on right now is trying to sort of extract all the boilerplate text from those packages and have it sort of like completely separate, so it can be reused by any other software, and then try to sort of reuse, to sort of work on sort of the method writing, the automation of the method writing, just by reading from a base data set and using that external sort of boilerplate thing. Then that would sort of then allow us to then move on to have something a bit more complicated. And another reason why we also want to sort of have a bits data set as input in our workflow is that in the long term, we also sort of want to sort of make the app, improve the user friendliness of the app. And one way to do that is minimize the time people spend on the app, right? So minimize the number of clicks people have to sort of do when they are using the app. Another goal of the project is that we want to reuse existing standards like BIDS. So where I'm going with this is that ideally what we want, or what we're aiming for, is for the app to be able to use as input either a BIDS data set or an IDM results that I'll talk about just a little bit later, and extract as much information from those standards so that all the parts that are related in the checklist to the data contained either in a base data set or in an IDM results, we want those parts to be completely filled automatically. The idea is that if you can fill in like half of the checklist automatically, then the user will spend less time and they're more likely to use it. Another advantage of this is that then we incentivize people to sort of use those standards to make their life easier when they want to write their method section as well. And then the rest of the workflow is pretty much what I've described before, except that now the user just not clicking buttons, he's just saying, okay, just read the data and metadata from that folder, and then the rest just happens more or less automatically. And also this way we sort of ensure that we avoid user making mistakes when they actually click buttons on the app itself, right? So that's another way you sort of remove sort of human error from the whole pipeline, I would say. So yes, another aspect that sort of that I need to mention is that another sort of paper or that came out that relates to methods reporting is about pet imaging. Came out a while ago, and this is related actually to an extension of the BIDS format that's coming soon, where BIDS will soon be able to allow sort of cover use cases when it comes to pet imaging. And that paper describes pretty much a lot of the things that are going to go in the BIDS extension for pet, and also comes with a table. So obviously I couldn't help but sort of try to turn that into its own app for pet imaging. And then when talking with Melanie, who is one of the author and one of the member of the BID steering committee about the app, she was like, well, there's another use for this that you've not considered, is that this could even be used when acquiring data. So the idea is that when you have an app that allows you to sort of centralizes all the information while you're acquiring data, you can sort of directly help with data curation that's going to happen downstream of this. One potential thing that can be done with this is that when you acquire data, you just use the app directly to say, okay, I've had that many blood sample during my pet experiment, for example, and this can sort of then output, once again, a JSONLD file that you can then use to create some of the elements of a BIDS data set. So this is another way where you can sort of make it easier to sort of, from the very beginning, make sure that your data set has been curated properly. And you, once again, remove potential mistakes and errors and human errors from the pipeline. And I am not sure why this is showing this. Okay, good. Okay. One aspect of this whole project that I need to emphasize as well is that it's fairly easy to extend to other checklists. So ideally, there's this idea of modularities that if you want to reuse items or set of items from one checklist to create another, then that's very easy. And that's actually just a side effect of just using the ReproSchema, which is very, very flexible when it comes to like if you want to recycle items or sections of a questionnaire, that's very, very easy to do actually. And this is actually kind of useful because there are more and more sort of checklists that are coming out to sort of help people in, I would say, subfields of neuroimaging to sort of, suggest what kind of methods they should report and how they should report it. One example that came out recently is the Artemis project, which relates to event-related potential in EEG. And we are actually in touch on this because they are looking for people to sort of create some sort of app for that. So, and they didn't know about the whole eCOBIDAS project. So we actually met at a live MEG conference where they presented their work. And I actually highly recommend you have a look at this talk by Susie, because she also emphasized the advantages of using checklists in general. Something I'm not getting into here, but her talk about this is excellent, and she sort of highlights the big success stories of using checklists when it comes to, obviously, aviations is something I guess we are all aware of that pilots use checklists. in their everyday life or in case of emergency, but maybe less known is the fact that checklists are heavily used also when it comes to surgery as well, and that the World Health Organization rolled out a couple of checklists for surgery that are been very, very successful as well. And if you're interested to hear more about this, actually, the next meeting for that project is actually happening next week. So if you're interested, just get in touch and feel free. We'll sort of link you up. And it's a fun, very dynamic project. I highly recommend to sort of like keep an eye on. Oh yeah, and another thing I should mention about this is that one of the good things about this project is that it's much smaller than the whole eCOBIDAS MEEG project. So it's sort of or checklist. So it gives us another sort of like way to sort of start working on a subset of items without getting drowned into sort of like the scale of those huge just spreadsheets. And so, and just maybe to highlight some of the work that's also happening at the moment is that, so the eCOBIDAS MEEG is finally officially out, meaning that the paper related to the report is out. Cyril Pernet, who is one of the main authors of the report, and I are working on, let's say, just refactoring all those different spreadsheets of items that we have and trying to create sort of sub checklists. One of the main goals would be to sort of first target those that are going to be most useful for most projects or many projects. So right now there are checklists that sort of exist that are very much work in progress. So they're not going to be very, so if you start using them, you're going to realize there's some things that are missing or just not there. But we started working on some of those, on participants and sample description, because that's pretty much a common point to, if not most studies, at least many studies, where you have to sort of describe your participant and your sample. For a lot of studies as well, it's very important to sort of describe your behavioral paradigm that you use. And on this, actually, another way we're trying to link up with some other either standards or ontologies that already exist. For example, the cognitive atlas and the cognitive paradigm ontology are things you can reference into your BIDS data set. And similarly, the hierarchical event descriptors is a very rich way to describe your events when it comes to EEG and MEG. It's been extended to MRI, and it's also part of a typical BIDS data set. So rather than reinventing the wheel, we're going to sort of try to sort of link up with the work that's been done there to try to sort of make our life easier in the future. And one of sort of the also low-hanging fruit would be try to identify, or I mean, we have them, but try to create a checklist for all the sort of acquisition details that common to all MRI sequences, whether you're doing just purely structural or functional or DTI, you name it. All of those sequences have a set of details that are common to all of them, and we want to sort of create a checklist for all of them. The good thing about that one as well is that most of them are also covered in a BIDS data set, right? So that's another way we can sort of link things together. Okay, I'm getting close to the end. I have no idea how I'm doing in terms of time. I usually tend to talk way faster than I should. But how you can help, I suspect the best way to help at the moment is sort of use the app, try to see if there is anything wrong, see if, tell us how we can improve and what to improve. I know that Sanu is actively looking for people to help her with the user interface. So if JavaScript is your jam, I think she'll be very happy to sort of have any kind of help on that front for sure. Also, yeah, I'm not going to list all the way we can improve the user friendliness, but some things we're working on is sort of, once again, we don't want people to sort of start typing responses. So we want to create set of response options for as many items as possible. And that takes a bit of time. And as well, for quite a few of the spreadsheets and the checklists that we have, we still need to implement some of the branching logic that I was mentioning earlier. The idea that if you, depending on the response on you give to one item, then you might be exposed to some other items down the line. So this is something that still needs to be sort of implemented in many of the checklists. The good thing about this project overall is that you don't necessarily need very advanced technical skills to actually be able to help. If you are, if you're just like, a Python and a Git wizard, you'll be happy, you'll find stuff to do, that's fine. But if you just want to work with spreadsheets, that's okay. There's plenty of work to be done there. I'll be sharing the slides, and that's a link to all the different spreadsheets that we have, so you can see just like how much work there is to do. So yeah, clearly that's the type of project where yeah, technical skills is not a very it's not like it's very low bar of entry, I would say. And also in general, I would say that if there's anything missing, meaning that you are using a certain type of technique when it comes to MRI, to a certain type of analysis, whether it's univariate, multivariate, and so on and so forth, and you see when browsing through either one of the checklists or one of the spreadsheet that there's something missing, or that if you were a reviewer, you would ask for this, and that this is not currently covered by eCOBIDAS. I know there are several things like this. Then get in touch because there are plans for eCOBIDAS 2.0 for the MRI part. So the idea of the old eCOBIDAS project, whether the MRI or the MEG, is that they're not set in stone and they're meant to evolve, and they're going to go through versions. So there's definitely room for improvement and room for things to be added. So do not hesitate to say, hey, I think this should be mentioned. And this can definitely be added in a later version. Okay, I think that is it for me. Yes. I will stop sharing my screen, and I think if there are any comments or questions, I'm happy to answer them.
Great, thank you very much. So everyone is in control of their own speaking voice, and be careful with your mute and not, but people are encouraged to ask questions if they have. I may start things off quickly with, so while the complete eCOBIDAS is really cool and very extensive, if someone wanted to come up with not quite eCOBIDAS, but it's sort of a publication checklist. If some of the stats people wanted a quick checklist for the things that this should have. I know eCOBIDAS covers it, but there may be sort of shorter versions of things. If ReproNim wanted to characterize publications, if they were sharing their data or not. So it's just sort of more ad hoc, additional types of characteristics. They're not quite eCOBIDAS. Are those types of things that could be prepared in the same way and sort of linked to the appropriate parts of eCOBIDAS, but be sort of separate checklists? But
I mean, that's definitely doable. Like, it's not, the idea is that because all of that under the hood works with ReproSchema, which is highly modular, you could clearly just do that fairly easily. It would not be either by just creating your own checklist by picking some items that already exists in the sort of like, let's say, the eCOBIDAS thing, or by having a spreadsheet and just like creating your own items that you can then supplement to some things that already exist. So this is like, yeah, this is clearly easily doable. At the moment, like it's not yet there, but that shouldn't be too much of a problem to actually do in practice.
Okay, great, thanks. Are there questions out there?
Maybe just one quick remark. First of all, thank you very much, Remi, for the talk and it's a great project. One quick maybe plug or sort of maybe suggestion is to, if you want those things to be adopted, one good way is to actually approach the journals, the publishers, the such that if we can make those recommendations sort of like more incentivized, then they have like a good chance of and since they are here to actually mend that problem that you were describing from Josh Carp papers, so that's so I'm thinking of Aperture, of course, but there are many publishers or journals that possibly would be interested. I know that the INCF has a new working group that is trying to see what kind of recommendation we can put to the Journal of Neuroscience. So there are 60 journals in neuroscience that are part of that consortium, and that consortium can be used to say, hey, what about adopting that kind of recommendation or in general. So maybe the eCOBIDAS could be like one aspect of that. So that was maybe more like a remark or suggestion than a question, but it's wonderful to see this happening.
Yeah, no, this actually has been on the radar. I think almost, I wouldn't say almost from day one, this has been one of the things like, yeah, if you can sort of help editors and reviewers life, that with an app like this is definitely something that we sort of want to sort of put forward. The thing I'm never sure is like how finalize a product we should have before we start getting in touch. That's always the issue where I'm just like, I mean, there's also the issue like you want to get, maybe you want to get some of the editors and some of the journals on board very early so they can give you feedback on what their needs would be as well. But right now I've been a bit overwhelmed with just all the other aspects to start thinking about that. But if anyone has any input or suggestions or could put me in touch, I'd be more than happy. I know I've meant to sort of work more with INCF. I just have been not had the time yet.
Thank you.
Okay, I see a raised hand there.
Yeah, thank you for the talk. I actually have a comment regarding the previous discussion. Maybe you could start with the preprint repositories, because you don't really have strict requirements regarding the shape of the manuscript. So maybe you could implement such tool for like preprint repositories, and then those methods will be judged in peer-reviewed journals.
I'm not sure how that would work. Would it be like when people post, like say a neuroimaging preprint, then you have a link to the app that sort of
before they publish the preprint, you can present them the option of, hey, if you want to use this tool to write the methods, you can test it, and then you could maybe get feedback about some kind of issues that the peer-reviewed the reviewers then raised regarding those method sections.
Yeah, the issue is like usually it's where to catch the authors before they post the preprint. It's like, how do you make sure they know the tool so that they can actually use it before they post the preprint? That's a bit of a
via Twitter.
Yeah, exactly. See, it's either a chicken and egg problem or just like, just advertise it in some other ways.
Yeah, and one more question is, because you mentioned that the original COBIDAS paper had over 500 of remarks, right? Those in this original checklist. So how do you choose which one of them land in your web-based app? Because assuming that people will generate the methods based on your web-based app, that's a lot of power over the overall shape of the method sections throughout the years.
So, okay, so there are different aspects to this. So first of all, the original, 500, I think 500 was like when you combine MRI and MEG. So if you just have, and that was the original one. I think now if you, just MRI would be 400-ish now because things have expanded. So the original report for MRI had mandatory item and non-mandatory item. So that would be, I guess, a first way to filter and just make sure that people just, if you only report the mandatory, you could have like let's say a short version of the checklist where you only have the mandatory items. Another way to sort of start sorting through or saying which item are more important than others would be to, for example, use some of the start just ranking items by you know which ones are most often reported, so make sure that those are covered first. That you can do by sort of using the data we have from Joshua Carp's paper that says, okay, that type of item is reported that often, right? So this way you can sort of create some sort of ranking and say, okay, you report this and this and that, and then sort of slowly you hope that you can improve the literature by just making sure that people report at least these items first, and so on and so forth. But at the moment, we have not, we're still sort of like overwhelmed by the size of it all, but that's definitely something we're keeping in mind about how to sort of like select items to make sure that it's going to be easier. Another thing is that those 400 items cover all types of MRI and all type of analysis. So if you've only done like univariate on functional data with one anatomical scan, this is going to drastically reduce the number of items you're going to have to fit in, right? And similarly, like if you've not used any kind of fancy MRI sequence, the number of items also drops. So this is like, you would only have to fill in 500 items if you've done diffusion, if you've done ASL, if you've done all the things all together, then that's what you would have to do. But I suspect that that's very, very few people actually are going to be faced with that many things to actually fill in.
Thank you.
Okay, thanks. We can still chat a little bit more, but since we're coming near the end of the hour, I did want to say good thanks to those who have joined and have to go. I also want to get on tape here that next month's first Friday is happening back on the first Friday. It'll be our TR&D1 discovery team talking about how to build your own ReproPond, and it may be Jeff and David Keeter and Al Crowley and various folks talking about that. So I wanted that on the record here. So any more questions? Oh, and PJ put something in the chat, the links that are in the slides. Hopefully we'll be able to share those slides and people can get to those links. Okay.
I'll send you an email after that to say.
Okay, yeah, we'll put it in our.
Is that good? Okay, cool.
Yep, great. If there are no questions, we know where to find you. Everyone knows where to find ReproNim on the web and other places. Feel free to continue the dialogue as we go forward. So thanks, everyone. Thank you, Remi. And we will see everyone next month.